Assalamu alaikum students. Now we start chapter 2, set function and groups. Exercise, I think we done last week exercise 2.1. Now 2.2, operation on sets. First of all, union of two sets. Do you have two sets A and B? Then union is noted by A union B, the set of all elements which belongs to A and B. Symbolically we written as A union B is equal to X, such that X belongs to A, or we sign denote or X belongs to B. And then this is example, all elements written in union. And then intersection of two sets. The intersection of two sets A and B denoted by A intersection B is the set of all elements which belongs to both A and B symbolically. X such that X belongs to A, and there we note a sign of or, and in this set we represent it by and X belongs to B. The above sets A and B intersection is 2 and 3 because two common element 2 and 3. Next is disjoint set. If the intersection of two set is empty set, then the sets are said to be disjoint sets. The set of odd natural numbers, the set of even natural numbers, these two sets are disjoint because they have no common element. Overlapping set. If the intersection of two set is non-empty but neither is a subset of the other, the set are called overlapping. If some elements are in common, L contains 2, 3, 4, 5, 6, M contains 5, 6, 7, 8, 9, 10, and some elements are in common, these sets are called overlapping sets. Complement of sets. The complement of a set A denoted by A dash or AC relative to the universal set U is the set of all elements of U which do not belongs to A. Symbolically, A complement is equal to X such that X belongs to U and X is not belongs to A. All those elements do not belongs to A but belongs to U. U contain set A. If U is N, then E complement of E means even numbers, is equal to odd, and complement of odd is equal to even numbers. Next example, U set of alphabet of English language, C set of consonants other than vowels are called consonants. Then complement of consonant is vowel and complement of vowel is consonant. Difference of two sets. The difference of a set of two sets A and B noted by A minus B consists of all the element which belongs to A but not belongs to B. A minus B symbolically written as X belongs to A and X not belongs to B. And in B minus A, X belongs to B and X is not belongs to A. Like example, A and B, then A minus B, we eliminate element of B from A, and when we write B minus A, we eliminate element of A from B, and these two sets are never equal. Some exceptions may be possible. And A complement also written as U minus A. Next topic is Venn diagram. Venn diagram are useful in demonstrating visual the basic concept of sets and relationship between sets. They were first used by an English logician, mathematician, John Venn. In Venn diagram, a rectangular region represents a universal set. Box is called universal set. The region bounded by a simple closed curve represent other sets, which are subset of the universal set. For the sake of beauty, these regions are generally shown as circular regions. In this set, A shaded by blue color and A complement shaded by light blue. Next, these are the all possibilities when two sets are given. In first box, A and B are disjoint. In second, A and B are overlapping. In third one, A is a subset of B, and in fourth, B is a subset of A. In union, you shade all these circles. But in second line, in intersection, disjoint means no common element. And in sixth box, you shade only common area. And 7 and 8 also. And in third line, A minus B means we eliminate element of B, only shade element of A. In 10th box, 11th box, you see A is a subset of B. It means no elements other than B in A. It means it contains no set, empty answer, and no shading region. Also in the fourth line, B minus A, we shade B instead of A. And these are some important conditions. A and B are disjoint sets. It means their intersection is empty. The number of element A union B is equal to number of element A plus number of element of B. If A and B are overlapping, now you know the difference between disjoint and overlapping sets. In overlapping, intersection is not empty, and the number of element of A union B is equal to number of element of A plus number of element of B minus number of element of A intersection B. In this case, we minus the common element. In third condition, A is a subset of B, and then if we find their union, it is equal to B, the superset, greater set, and B is a subset of A, fourth part, then union is greater set now is A. If A intersection B is empty, it contains no element. Not empty, it contains some elements of A and B. In seventh, A is a subset of B, then their intersection is the smaller set. Also in condition 8, intersection is equal to the smaller set and union is equal to the greater set. A and B are disjoint, then A minus B is equal to A. We have done in last page Venn diagram. We shade in disjoint A minus B is equal to A, and if A and B are overlapping, then A minus B means number of element A minus number of element in their intersection. A is a subset of B. A minus B is empty set and B is a subset of B. B is a subset of A means A minus B is empty set. Not empty because we have done in last Venn diagram page these examples. In 13, A and B are designed same like 9 part. A and B are overlapping. E is a subset of B. B minus A. And then B is a subset of A. B minus A is empty. Some important notes. A union, since the empty set contains no element, therefore no portion of U represent E. If in the diagram given on preceding page are place B by the empty set, imagine the region represent B to vanish, then we get the results. A union empty set is equal to A, intersection empty set is equal to phi. A minus empty set is equal to A, empty set minus A is equal to empty set. Also, if we be replaced by A, then union of same set is equal to A, intersection of same set, A minus A, empty set. And then we union of A with universal set is equal to U and intersection is equal to A. A minus U is equal to empty set and U minus A is equal to complement, is called complement of A. Venn diagram are usually only useful only in case of abstract sets whose elements are not specified. It is not desirable to use them for concrete sets like you have given set or you have some problems without set. Next, this is exercise 2.2. In first part, these are the same result shown in the last pages we done in Venn diagram. If you have A in part 1, A is a subset of B, and you have to show on these union and intersection. The upper diagram shows union and the lower 7 number shows the intersection. Same, B is a subset of A, B inside the A, union both set and intersection only B. And A union A complement means whole diagram, A inside the circle and A complement outside the circle, both are shading. A and B are disjoint sets. If we want to show their union, both circle are shaded, and if intersection, empty set, no shade. In last part, A and B are overlapping, then whole diagram is whole circle are shaded, and in intersection, only common area shaded. Same is A and B are overlapping in first part and their answer below their question. A minus B means we shade A only, and B minus A we shade B side, not A elements. Second part, A is a subset of B, then A minus B is not possible, empty set. And in next below 15 diagram shows B minus A. Third part, B is a subset of A, 12 and 16 diagram. If we want B minus A, in 12 we show A minus B, and in 16 we show B minus A, which is not possible, so no shading region. Next question number 3. These are the sum result we discussed in the last pages, and same is there. In first part, A union B is equal to A if B is a subset of A. In union of two sets, greater set is answer. Same in second part, A union B is equal to B if A is a subset of B. A minus B is equal to A if A and B are disjoint set. Some examples are given side by side. A intersection B is equal to B if a B is a subset of A. And in next, number of element of A union B is equal to number of element of A and plus number of B, means intersection is empty, disjoint sets. Next is number of elements of A. This is possible if B is a subset of A. If you have some element in example and then we verify this condition, A minus B is equal to A. Repeat question. Number of element of A intersection B is 0. This means disjoint sets. A union B is equal to U. It means either A is equal to U or B is equal to U. Fifth is commutative property of union. Next, number of element of A intersection B is equal to B. Then it is B is a subset of A. U minus A is empty set. It means A is equal to U. Both sets are equal. Question 4 is easy. We given U universal set, A set, B set and C set, and then some conditions. A complement is equal to U minus A. Eliminate element of A from U. B complement also like this. Eliminate element of B from U, and A union B, all elements, no repetition. A minus B, we eliminate element of B from A. A intersection C, common element of A and C, and then A complement union C. A complement already we find in part 1 and its union with C, and last is complement of U means U minus U, same sets, it means its result is empty set. Shown by Venn diagram. A complement U minus A. Then A complement means outer side of the circle A intersection U is equal to A union U is equal to U, A union phi is equal to A, phi intersection phi is equal to phi. No Venn diagram. In these sets we verify property with Venn diagram. In first part, A minus B is equal to A intersection B complement. If two sets are given, there are 4 possibilities we have studied in Venn diagram page. These 4 are, they are disjoint or overlapping, or A is a subset of B or B is a subset of A. We use their disjoint property, disjoint condition. If they are disjoint and we find A minus B, only shade A side, and in B complement we shade outside the B all area including A, and it intersection with A is equal to A, because in intersection we shade the common region. So these two conditions are verified. In this we take their overlapping condition A minus B, we shade A only, not the overlapping area, and it's then complement other than the shading region, all area surrounding it inside the box, and then its intersection with B, it's equal to B, which is the answer. Okay boys, okay students, it's all over. Exercise 2.2, do these questions, and if you have any problem reply me. Allah Hafiz.